Well, I don't know about you, Richard, but it's not every day that I get to co-chair a meeting that has in attendance former FRA administrator and a former commissioner on the ICC. But I guess I want to extend a special welcome to Mr. Rudder and Judge Emmett. Appreciate you coming today, both of you. And uh, Richard, if you have anything, welcome everybody. Glad to see you're here. Hopefully you all managed the hurricane well and have power and are doing all right. Richard, any opening comments you want to make?
Yeah, Bruce, no, I just want to echo the thanks to our those who will be presenting today and hope everyone is doing okay. We continue on the railroad side of a recovery of our operations. At one point had hundreds of generators that were out at different signal locations to help keep things moving, but continue to address some of those issues into this week and probably in the weeks ahead. So appreciate everyone's patience for slow moving trains, and then just overall for the teams that are helping us to keep getting things back to normal. But yeah, again, echo everyone's thanks. Appreciate the attendance today. Look forward to hearing the presentations as well.
And with that, Sydney, you want to take us to where we need to go?
Yep. Okay. So we've already done our openings and our welcome. So again, welcome. My name's Sydney Liggins. I'm senior planner here at HGAC and helping to run the Greater Houston Freight Committee. Today we'll have three presenters. Our first presenter will be Judge Ed Emmett, who will be presenting on the history of Houston's freeways and what does that mean for the future. We'll have two other presentations. One, Amanda, the TxDOT representative on innovative intersections. And then the last one will be a presentation from Mr. Tyson Muller about Union Pacific milestones in Houston, recent achievements and future innovations. Then we'll have a couple of announcements for future meeting dates, and then we will adjourn. So I will go ahead and turn it over to Judge Ed Emmett to start his presentation.
Good, thank you very much. I assume my deck of slides is there. We almost. Those are my balloons. No, they're not. Good. I've got 20 minutes to present what is really the result of what started out to be a one-year project, turned out to be over a two-year project, where we did research into the history of Houston freeways. And how did it come about? Well, quite simply, as hopefully most of you remember from my first presentation, in talking about future freeways and rebuilding freeways, suddenly there appeared a spate of articles and headlines from New York Times and NPR and all kinds of other places saying things like highways destroyed hundreds of urban neighborhoods, or removing urban highways can improve neighborhoods blighted, or a brief history of how racism shaped interstate highways. And it caused me and others to go, what really happened? Who really was displaced and why? And then what's the lesson that we can learn from that? Well, so we started, if I guess we can move to the next slide. We said, let's start where we live. Let's start and talk about Houston, because if we can create a methodology and do research on the Houston freeways, then hopefully we can create a template that can be taken anywhere else in the country. So that's what we did. And the next slide shows the methodology. Now, there won't be a quiz over this, but it's complex. And basically what the researchers here at the Baker Institute and Rice University did, we went back and got every detail about buildings that we could that were in the alignment of the freeways. and those mainly were Sanborn Insurance maps because they actually drew the buildings. And archival databases did great research down at the city of Houston and in the county and in TxDOT. And then we thought, okay, now we know the buildings. What do we do with it? Well, the logical thing was to tie it to census data and find out who lived in those buildings. And then later we could find out why that particular alignment was chosen. Ran into a bit of a hiccup early on when we realized the 1960 census data won't be released in detail for several years. So at first I thought, well, that kind of screws up the whole research. But in fact, it didn't, because we came to the realization after looking at all the freeways, they were pretty much all designed by local officials and were designed well before 1960. And the interstate highway system didn't even exist yet. So when the interstate came in, or the highway system, Federal Aid Highway Act, they basically took alignments that had already been made by the city of Houston and TxDOT in Harris County. So that helped, because that meant we could use the 1950 and the 1940 census. But then the real realization that I think changes everything that anybody needs to look at about this. If you read the articles and if you read some of the reports that have been done, they talk about who lived in the path of the freeway when the right-of-way was acquired or when the freeway was built. Well, that's a false date, particularly if you're talking about the highway planner's role in this. The key date is when was the highway aligned, because that's when somebody made a decision to put a highway through a particular section of town. It's not by the time the right-of-way was actually acquired, or certainly by the time the highway was built. So in that case, we were able to use the 1940 and 1950 census data appropriately and go freeway by freeway. So the next slide will show kind of how we did it. Right? There we go. Color coding talks about commercial buildings, residential buildings. This is just an example of how the research team, and we had a team of 6 or 7 people, and the geospatial mapping folks here at Rice could go in and talk about which buildings were actually taken. And so then you go back and say, okay, who lived in those particular residences at the time? So that does allow us to come then to a result. And the result is interesting. So next slide. If you go freeway by freeway and you look at the census used, for example, the East Tex Freeway, we used the 1940 census because it was aligned during the 40s and before 1950. Anything that uses 1950 was aligned during the 50s. But you can't match all of them. So if you look, and I can go over some in specific if you have a question, you look at just the residential structures, we were able to only match 47%. But that's a pretty good number. If you try, the unmatched were a lot of reasons. Census takers weren't always as adept as they possibly could be. Others, you just couldn't find the right address. But so we matched roughly almost half of the residential structures of all those freeways. The census 1950, 1940 really only had 2 categories. 2 categories were Negro and white. We've changed reference to black and white. And that will show you freeway by freeway who was displaced. And it's no surprise, for example, the 4th Ward was overwhelmingly black. Some others came up with real surprises. So when we looked at that, we thought, okay, well, what are the key factors that went into this? And at that point, again, most of the freeway system in the Houston area was designed before the interstate highway system even existed. So you really can't blame the interstate highways. But the narrative that has been put forth, claiming that freeways were purposely designed to destroy or marginalize minority and economically disadvantaged neighborhoods, oversimplifies the facts, and in some instances, completely false. The error made most frequently, again, is to assess the impact of a highway based upon who was displaced by the right-of-way acquisition or the actual construction. So once more, let me say, if you're going to decide the intent of the highway planners, you have to go back to when was the alignment decided, because that's the key thing that the highway planners had to do with. If, for example, a freeway was aligned to go through a neighborhood that saw a major change in its racial profile after the alignment, but before construction, you really can't blame the highway planners for displacing people who moved into the neighborhood after the route was already determined. And the most surprising example of that, if I mention Kashmere Gardens, everybody knows Kashmere Garden is a black neighborhood. In 1950, it was 83% white. You go back and look. And in fact, that's even on the website of the city, I forget what they call those groups, super neighborhood that represents Kashmere Gardens. It's even on there. So you had a white neighborhood, freeway was aligned through it. It became a black neighborhood, not just because of the freeway, but who knows what. So you have to keep that in mind. So after we look at the numbers, there is no question that the black population was disproportionately impacted. 41% of the people displaced were black. The population overall was about 20% black. That's been true for a long, long time, but during all the highways. So how do you explain this? Well, we have to recognize our sordid past. During the period of freeway planning and development, societal norms and systemic racism reinforced by government policies created a segregated residential pattern. And if you go back and look at city documents, they even designate these are black neighborhoods. Several of those designated black neighborhoods were obviously densely populated and near downtown. So as a result of the desire to build freeways to serve downtown Houston, guess what? Those freeways necessarily went through those densely populated black neighborhoods in close proximity to downtown. There really wasn't any other way to get there. So it's no surprise that the number of people displaced once those freeways got closer to downtown were disproportionately black. In fact, if you look, of the black residents who we identified as being in the path of Houston's freeways when they were aligned, 89% lived in the 3rd, 4th, or 5th wards near to downtown. So that's where the vast majority of the displacement occurred. What about other notable black residential areas that existed in the 40s, 50s, and even the 60s, such as Acres Homes, Independence Heights, Frenchtown? Well, some things cause me to pull my hair out. And when I hear somebody stand up and say, the North Freeway destroyed Acres Homes. No, in fact, the North Freeway purposely avoided Acres Homes, went to the east of it. If it had stayed on the old US 75 alignment on Airline Drive, it would have taken out a huge chunk of Acres Homes. But in fact, the highway planners moved it to the east, put it over the White Oak Bayou watershed. That's created other issues, and we don't want to get onto the North Houston Highway Improvement Project, but that's a lot of that. Likewise, North Freeway avoided Independence Heights. East X Freeway bisected Frenchtown. People can go back and look and say why, or could it have gone anywhere else? but that's a fact. It did. Later, for reasons undetermined, several linear blocks on the south side of Independence Heights were removed when the North Loop was shifted north a few blocks, and that caused a significant displacement. These are all things that people will need to look into later. There's also considerable evidence that highways were viewed by city planners as a tool for urban renewal through the removal of neighborhoods considered blighted. Now, people can go back and argue over what's blighted and what's not. Pardon my phone for going off. I never get phone calls here. I don't know what that's about. Surely it'll stop soon. Good. Best example of that is the Fourth Ward. Several locations, sections of the Fourth Ward were removed to make room for downtown civic projects and for the development of the San Felipe Courts public housing project, which, by the way, when it was built, only white people were eligible to move into. So if you take that whole part of the Fourth Ward, it's already been taken away for civic projects and public housing. So when the freeway comes through, again, you can't really blame the freeway for that. Now, people can go back and argue over the urban renewal. Was that the right thing or wrong thing? We're looking at highways, and we're looking at their role in all this. So the section of the freeway that connected the North Freeway and the Gulf Freeway certainly removed much of the historic Fourth Ward, but most of that area had already been affected. Another area in which the debate over the impact of highways on minorities and economically disadvantaged residents misses the mark is again the current status of that. You have to go back and say, okay, what was there when the highway was aligned? We've got neighborhood after neighborhood that have changed dramatically. And I think I saw Robert Sakowitz on this. See here, there he is. He, along with many others, could explain that the South Freeway, with 288, that neighborhood has changed dramatically over the years several times. The western section of the Third Ward was overwhelmingly white, as was the southern section. Then the highway was aligned. The part that was closer to Main Street became overwhelmingly black for a while. Then the freeway went in, and now, guess what? It's the museum district. It's going back totally the other way. So you just really can't look at what's there now and do that. If you look outside of the downtown area, you can find with each freeway all kinds of examples of decisions made to either go through or avoid neighborhoods. Graduate of Bel Air High School, Loop 610 went right through the residential area of Bel Air, an overwhelmingly white neighborhood at the time. So taking into consideration all of the facts, the routing of Houston's freeways relative to minority and economically disadvantaged areas really wasn't done with racist intent, although many of the affected neighborhoods were deemed blighted and poor, largely due to racist segregation and neglect over the years. The disproportionate displacement of Black residents resulted, I think, from imposing what was considered at the time the most efficient highway system on segregated housing patterns that were created by a racist society. Now, additionally, in the view of some urban renewal advocates, again, they were rightly or wrongly thinking they were improving living conditions. I don't find any evidence, though, that there was much effort for whatever reason Black residents were displaced, that there were accommodations made to improve their living conditions somewhere else. So, that's kind of, let's go to the next slide, because this kind of wraps everything up. I'm not going to go through it all again. This is what you have to remember. But when you get down to the last, you then have to look at what were the alternatives. Where else could you have run those freeways, particularly if you're going to run them downtown? There wasn't any way to get around it. So that's just the circumstance. Now, I have to mention reconnecting neighborhoods. Secretary Buttigieg just talked about it. That's just such a false promise, because the neighborhoods that existed at the time were segregated by racist policies. Why on earth would anybody want to say, okay, we're going to go back and recreate something that was based on that? But the other reality is the neighborhoods have all changed. You can't go back and reconnect something that no longer exists. That's not to say, however, that there can't be improvements in the building of highways so that the neighborhoods that exist now, the communities that exist now, won't be as disrupted as they were by the process. So that's a 20-minute run through of what took about 2.5 years. And I'll be happy to quickly answer any questions you might have or comments. This is one of those things that I fully realize once you put it out there, then it's like so many things that are political. People on one side or the other are going to just say they disagree based on emotion. But these are the facts, and this is what we put together. And the good news is that the team has created a template that can be used in other cities. But I think the real key, if I have to go away with anything, it's you got to look at the date the highway was aligned. If you're going to blame something on the highway, that's the decision the highway planners, that's the time the highway planners made the decision who was going to be displaced. So I think I got in under time.
Thanks, Judge. So I'll start off with the first question, and if anybody has questions, please just raise your hand or put it in the chat. But was there one thing that you would say was a big surprise to you as you went through this that you kind of weren't expecting?
Oh, I don't know that it would be a surprise. I think the revelation was in reading all the literature up to this point, people talked about who was displaced when the highway was built. And that's not the right thing to look at. The right thing to look at is the alignment. In terms of specific surprises, yeah, the Kashmir Gardens thing surprised me a great deal. I'd always known about, the McGregor area and that area, how it had changed over the years, but I didn't realize quite how much something like Kashmir Gardens had changed, or even Lindale Park. I mean, any number of them. And of course, the other thing that we're dealing with now, we're dealing with a Latino population now that just didn't exist back in those days.
Thanks. Does anybody else have any other questions?
Cool. It's an easy group.
How long did you say the study, or how long did it take you all to gather all this data?
Almost 2.5 years.
Oh, okay.
Let's see. Well, if nobody else has any other questions, thank you very much, Judge Emmett. Very enlightening presentation. Obviously, a lot of work behind it, and in 20 minutes, you're probably only scratching the surface. But
I did. Let me add one more thing real quickly before I drive to San Antonio. There will be a website that's active that you'll be able to go in, and you'll actually be able to take any section of any freeway and look at it for yourself and see, who was displaced, and you'll get the historical documents that tie to that as to why that freeway ran where it did. And, one example that I didn't have time really to get into, Lyons Avenue was a huge commercial center for not only the Black community in Houston, but really throughout the South. And it was severely disrupted by the freeway going in, particularly the way it blocked one end of it. But those are all things that people have to consider, and it's a fun project. Robert has his hand up.
Yep. Can you hear me?
Yes.
Mhm.
Judge, was the matter of fairness of compensation for displacement ever brought into this in a profiling of any way?
No. And we talked about it.
Yeah.
But, people who own the property were compensated under the eminent domain at the time.
Mhm.
Now, further research that really could be interesting. We talked about how the neighborhoods changed remarkably after alignment and actual construction. Well, this is anecdotal, but I firmly believe that a lot of the people who were physically displaced when the highway actually got there were renters.
Right.
And
They weren't the owners, so they didn't get compensated.
so
Exactly.
they didn't get compensated at all.
Right. Right.
And there was really no provision made for them to find a place to live.
Right.
So, I mean, we have to recognize that. But
Yeah.
again, that's not something you can blame on the highway.
Nope.
That's those are other policy. But
Right.
yeah, there's no question that in all kinds of neighborhoods, once they knew a highway was coming in, people who owned the houses moved out, but they rented them until they were actually taken down.
Okay.
Mhm.
Thank you.
With that, Tyson?
Good afternoon, Judge. So
Well,
just a question.
This isn't fair because I'm going to have to leave and I won't get to ask you questions about yours.
Well, what's not fair is I didn't understand that I had to follow you in a presentation. So touche. As you did the highway work, did you add any components from the rail side as far as when the railroads were constructed along with the highways? Because that's an interesting look, because as you know, the railroads were probably put in place 100 years, almost 100 years before the highway interstate. So you could overlay that, right, for someone who's not educated there.
Well, and in fact, the website does overlay the railroads, and there are examples throughout where, the original highways tended to follow the railroads. And so, for example, the near downtown area of the Fifth Ward, one reason Frenchtown got bisected was the freeway couldn't move off Jensen very far. It couldn't move to the west at all because that's where all the railroad intersections were, particularly at the time. And that, since you brought up railroads, again, now we look, and so many of them have been taken up. But back in the day when the highways were being designed, there were railroad tracks all over the place. And that made it more complicated. And the other thing, not to belabor, highway planners didn't want to mess with railroads. It was just too much. If you start trying to compensate a railroad or move a railroad, that's a problem. Likewise, on the East Freeway, one of the reasons it went as far north as it did was it couldn't intersect with a lot of the industries that were closer to the ship channel. Highway planners didn't want to have to buy out some steel manufacturing facility or something. So that's part of it too.
Yep. Thank you, Judge.
Thank you.
Judge, I just had one quick question. When is that website that will be on the Baker Institute?
It will be. This thing is going through academia's editing process right now,
Okay.
which is something I'm not used to. But so I'll let you know when it's up and live, but the results are all in.
That's great. No, fascinating information. Appreciate your continued updates.
All right.
Travel
I
safe.
have one question. I'm so sorry. Did you say that a copy of the study report is available?
No, it will be as soon as it
Will
finishes.
be. Okay.
Everything
That's gonna
else.
accompany the website, right?
Well, the report will probably come out even before the website.
Okay.
But the website will be interactive and people have to really make sure it works before we launch it.
So is that academia review process slower or faster than the government?
Let's say it's a bit more rigorous. Even into, and this is not a criticism, but citations
Right.
are very necessary in any academic report. And if you can't cite your source, then you're in trouble. So we're working through all that. All right. Thank y'all.
Thanks, Judge. Have a
Thank you.
safe trip.
Bye.
Travel safe.
Sydney, I think that brings us up to Amanda. You're on mute.
Thank you. Yep, it sure does. So Amanda Austin, she's a professional engineer from TxDOT's design division, and she'll be giving us a little presentation about roundabouts. So I'll turn it over to you, Amanda.
Awesome. Thanks so much. Let me get my screen shared here.
And while Amanda's doing that, I'll just say I saw Amanda present this at the Freight Advisory Committee that Judge Emmett chairs, and I thought this was so cool that I asked Sydney to invite her over to come and present it to this group because I thought it was pretty innovative and cool for us road kind of nerds. So go ahead, Amanda, and thanks for coming.
Yeah, thanks for having me. I really appreciate it. I really appreciate getting to present to the Greater Houston Freight Committee. I may be based, my job is based design division in Austin at our headquarters at Stastny, but I still live in the Houston area. I live in Spring, just north of the city. So I think I've crossed paths with several of you before when I was working out of Houston District, and I'm excited to come back before you in my new role. So I'll be talking about innovative intersections today, freight considerations in particular. I'll give an overview of what are innovative intersections. So for Bruce or anybody who saw me at the big freight committee meeting, I've got just a smidge more time. So I'm going to dig a little bit more into a few topics. I hope you find some new material there. I'll give a brief overview of my program that I head up. We'll dig into some freight considerations, but then I want to take some time to spotlight roundabouts in particular, and then especially accommodating oversized, overweight vehicles, which I think will be of importance to this group that we're talking with today before wrapping up. All right, so innovative intersections. What are they? What are we talking about when we say innovative intersections? Really, it's just any non-traditional intersection that reduces conflict points. So anytime you take a traditional stop control or signalized intersection and you do something to it geometrically to reduce conflict points, that makes it innovative. The most common is modern roundabouts. I bet you've driven through continuous green tees and might not have even noticed it. Median U-turns, R-cuts are really picking up in prevalence across the state. Displaced left, diverging diamonds are a real hot topic for engineers. They look real cool from the sky. I drove through one and didn't realize it until after I'd driven through one. So from the ground, it's you follow the signage, you follow the road, and then you're through it and you're like, wait, what just happened? So those ones are pretty cool too. I like all these. And then the SPUI, the single point urban interchange. So why are we doing them? Well, when you reduce conflict points, you reduce fatal and serious injury crashes. So it's about safety. Or R-cut in particular, a study showed a 40% reduction in injury crashes and a 70% reduction in fatal crashes. An R-cut, real quick, is a restricted crossing U-turn. Basically, if you think of a median separated highway, like if you get on 290 northwest of the city as you head out of the city, and I'm talking like past Grand Parkway, headed northwest, Bryan District is looking at putting some R-cuts in that right at the edge of Houston District. And what that would do is the minor roads that come onto 290 right now that just have, gaps in the median to be able to turn left, you would restrict those left turns. So from the minor road, it's right in, right out. And to make the through or the left movement from the minor road, you have to turn right and then make a U-turn. So that's restricted crossing U-turn. That's why it stands for that. So that, just by reducing the left turns out of the minor road, can result in a really statistically significant reduction in fatal crashes. Now, roundabouts, the big red box in the middle, the reason I love these so much is that unlike some of the other innovative intersections, there's a huge speed component for roundabouts. And so lowering the speeds within roundabouts combined with a significant reduction in conflict points reduces fatalities by 90%, which is, I put it in bold, I put it in big numbers. I like it to sink in. I talk really fast about roundabouts, but I just want you to think about that. 90% reduction in fatalities. We don't have any other intersection type with that track record. We don't have any other tool in the toolbox that's that powerful for reducing fatalities short of fully grade separating. And of course, that is cost prohibitive in most cases. Now, if you look at fatal and injury crashes, that's the stats on the right-hand side of the screen there. This is from FHWA. If you convert a two-way stop control intersection to a roundabout, you'll see an 82% reduction in fatal and injury crashes, and a signal to a roundabout is a 78% reduction. So I hear oftentimes from the public, oh, this intersection isn't safe. When are you going to put in a signal? And that's just kind of the automatic response. And what this shows is that that shouldn't be the response. A signal doesn't necessarily improve the safety, but a roundabout would. The conflict points is a really big one. I'll dig in a bit more on roundabouts and what makes them so safe a little bit later in the presentation. But the diagram in the bottom middle there shows 32 conflict points in a traditional intersection, with most of the severe crossing type conflict points clustered in the middle there. That's your T-bone type collisions. And a roundabout, single lane in particular, does not have any of those severe types of conflict points. So they're a really, really powerful tool in our toolbox. Now, because of these safety stats, TxDOT decided to build a program for this. So my job title within Design Division is I am the Roundabout and Alternative Intersection Design Lead, RAID. We took that acronym. We've heard it from Georgia DOT. We really liked how it emphasizes roundabouts because they have the best safety record and they're really applicable in the most situations. You know, for instance, a diverging diamond is applicable in very particular circumstances, but roundabouts can be applied virtually everywhere. That said, that's the RAID team within Design Division, but we wanted to think bigger than just what we're doing in Design Division. And we know we need to partner with our TxDOT districts because they're the ones implementing the projects. So we devised this little infographic to describe how we're working together. So my RAID team in our Design Division at headquarters is equipping, supporting, and working with our TxDOT districts to implement this overall Innovative Intersections program. So what is this program overall? The vision of this program, as it's been defined, and this program was just stood up about a year ago now, the vision is to decrease fatalities by increasing these types of innovative intersections. It's very simple. Again, it's a safety-driven program. The mission of the RAID team within this program is to advocate for these types of intersections, help to demonstrate, communicate, convey the benefits of these intersections, help to educate. And educate is internal and external. We've got a lot of educating to do within our department on how to plan for and design and construct and maintain these types of intersections. But we also need to educate the public and our partners. You know, groups like this that we can reach out to and talk to, and we can hear from as well, so we can make sure that these projects are a success. So education and then support. A big part of what my team is doing is supporting our districts. So if districts are looking at some intersection options, aren't sure which is going to work best, maybe they're not sure exactly how to draw one, we have resources to help with that. Some key accomplishments to date for our program. We've had a task force stood up since last year. It's internal to TxDOT, but it represents, we've got 14 districts, 14 out of 25 districts represented on the task force. And the task force is the one that came up with this vision and mission and is developing a strategic plan for the program as a whole, and has over the last year been tackling some quick wins. We got a website up, we've got a database. This is a really great one. We have a database of all the innovative intersections across Texas. There's over 800. So if you go to our website, and I can get the link, or I think I saw one of my team members, Shannon, on the call. If Shannon can put in the chat our website, that would be great. And in the website, there's a database. You can filter for type of intersection. You can filter for district. You can filter for within 1,000 feet of a 1,000 feet or 1,000 yards. I think 1,000 feet of a railroad. So if you're looking at roundabouts near railroads, that's a really great starting point. We've begun outreach, education, and support. We've been visiting districts. I've been making a lot of presentations like this to help get the word out, to help create contacts, and to help get feedback for our program. And we just unveiled an ICE process. So that was established a couple weeks ago. A memo went out to all the districts that said, essentially, if you're reconstructing an intersection, you need to look at all of your options. You need to consider safety at your highest levels of planning for which type of intersection you choose. So that's a really big landmark for us, is to help, kind of open up that tendency to just go straight to signal and start thinking about other options. We're working on info videos, fact sheets. We're looking to unroll some training classes start of next year. Right now, the training classes, we've got to start with internal to TxDOT, but we are looking at how we can open that up to outside of TxDOT as soon as possible. The roadway design manual is in the process of being updated and should come out in September. And there's a whole chapter 14, that will be about innovative intersections. So keep an eye out for that. And we're going to supplement the RDM with design aids as well. All right, so that's my program. That's how we're doing it, safety-based. Now let's talk about how is this important to all of you guys. Freight considerations for innovative intersections. Big picture, most innovative intersections can accommodate trucks and oversized overweight as designed. Diverging diamonds, you're designing your right turns. Just if you design it for the biggest vehicle you've got, then you can do it. The diverging diamonds, as you can see on the top left here, have pretty gradual turns. It reduces your traffic signal phasing, which can be a big operational benefit. But some of these innovative intersections will need some extra attention to accommodate truck swept path. So the bottom picture is an R-cut. So that's that example I was talking about. It's a good picture of it. You might be able to see my mouse, but if you have a minor road, you're right in, right out. You turn right, you have to cross a lane and then get into the U-turn. And then we've got these small truck lanes here. Now, you have to pay really close attention to the U-turn alternatives, median U-turns and R-cuts, because whenever you provide U-turns for trucks, you have to think about your acceleration and deceleration lanes. Do they have the space to decelerate without holding up the free flow traffic? Do they have space to accelerate? I'm actually going to go back a slide. If you look closely, if you pull the U-turn here, it puts you into a right turn lane. What's nice about that is that you don't have to stop and look way over your shoulder to try to merge right away. You've got some time to get up to speed, but you do have to then merge into, if you aren't turning right, you need to change a lane to get over. So there's a lot of different ways to do that. And I think that for freight, we have to be careful. We have to know what kind of truck is navigating these intersections and what their needs are going to be. I will say again, though, with proper design, when you pay attention to these things, pretty much any alternative intersection can accommodate heavy truck traffic. This table is from the FHWA Restricted Crossing U-Turn Informational Guide and provides the minimum median widths for U-turn crossover type intersections. Now, roundabouts in particular, what I love about them is they actually provide advantages for trucks because of the U-turn situation and avoiding full stops. Let me talk for a second on U-turns. A really powerful combination for a corridor is medians to provide safety from head-on collisions, combined with R-cuts at the most minor roads to create right in, right out situations, but to avoid the trouble that can come from U-turns and trucks and high-speed U-turns and that sort of a thing. You put roundabouts at key locations along the corridor. And those three things combined create a really powerful safety package, because you're preventing head-on collisions, you're preventing left turn collisions, and you're providing safe U-turn environments at the roundabouts. So here's a picture of a modern multi-lane roundabout, and you can see that trucks can navigate the roundabout. I'm going to show you a video a little bit later that I think will help convey that roundabouts work very well for trucks for U-turns. Everybody's going the same speed, so a truck driver doesn't have to worry about, going very, very slow on a high-speed highway when they've just pulled a U-turn. Now, roundabouts do require strategic truck aprons, and you've got to know the design and check vehicles. Just like any other alternative intersection, you have to know what type of vehicles are navigating your roundabout. And one little tidbit for the trucking community that we're talking with them about, the latest roundabout design guidance from the Federal Highway Administration recommends straddle lane design, which is what you see in this picture here, which is when you have more than one lane, the truck claims both lanes. There are situations, and I think in our Bryan district, we are looking at constructing roundabouts that are big enough to accommodate 2 semis side by side, but that's because it's a very big truck generating corridor, and pretty much every exit they have is likely to have a truck stop. So very, very high truck traffic. But generally speaking, the majority of roundabouts that have 2 lanes entering, we would like to design for trucks to claim both lanes and to educate drivers not to try to pass trucks in a roundabout. So now that's kind of the high level for freight considerations. Oh, and I don't want to forget about rail. I know Tyson's still on the line. So some rail considerations with roundabouts. This one is very interesting. I have an ongoing call with some folks who are also on the ITE roundabout and grade crossing committee. Every roundabout and railroad situation is unique. We have a few in Texas where it's very, very close. Through Dangerfield, there's a railroad track right through the middle. It's not this picture. And then I don't know if you noticed on my cover slide, there's a brand new roundabout in Round Rock with the railroad going right through the middle and an overpass over the top, and it's working great. But things you need to consider. You have to consider with your roundabout, you have to consider both your vehicle traffic and your train traffic. So if you have a railroad that's crossing one leg of a roundabout, you have to think about when a train is coming through there, where are all the vehicles going to go? How long is the train going to sit there? Is it near a yard? Are they going to stop? Are they going to back up? How long is it going to block that crossing? So you have to consider all those options. It's a very heavy engineering judgment type of situation. You got to think about your gate placement, train speeds, frequency, and then where the crossing is located. Is it through the middle? Is it across one leg? Is it across 2 legs? How far from the roundabout is it? Is there space to queue in between the roundabout and the rail? Will the queue length get back into the roundabout? From the other side of the roundabout, can you see the train and stop ahead of time? There's basically a lot of questions, and we're working with ITE to come up with some guidance. Right now, there's not a ton of guidance about what to do with roundabouts and rail. And I would say, I think thinking critically, it can work sometimes, and it may not work other times. So you just have to look very closely. All right. So now let me zoom in a little bit on roundabouts. Let's make sure we're all on the same page for roundabouts. What are they? There are 3 main tenets for roundabouts. They're generally circular in shape, yield at entry, and slow speed environment. It sounds pretty simple, but when I say roundabouts, a lot of people think of these examples. So the Arc de Triomphe is not a roundabout. It is a circular intersection, and it is very chaotic. And then I don't know if people recognize the intersections on the right. This is here in Houston. This is down by Herman Park and the zoo. I drove through these a couple weeks ago when we took my son to the zoo. When you drive through one, you drive through one, you yield on entry like a roundabout, like you think it would be. And the very next circle you drive into, you yield in the circle. The people entering the circle have the right of way. So it flip-flops that yield on entry between the 2 circles, which is not typical. And these also are very large. Like you could theoretically circulate these circles at a higher speed, more than 30 miles per hour. So they don't really fit the definition of a modern roundabout. I also throw in if some East Coast style circles, or some I've seen in Texas where they didn't really maintain the striping, or it's just kind of open-ended. If you have multiple lanes going into a roundabout and you have to, into a traffic circle, I should say, and you have to change lanes within the circle, I would not consider that a modern roundabout. Modern roundabout should be designed that, typical to a traditional signal, you choose your lane ahead of the intersection and you follow that lane through the intersection. We know that at a signal, you should not be in the middle of an intersection changing lanes from the left turn lane to try to go through. So it's the same with modern roundabouts. You want to pick your lane ahead of time, follow it all the way through. And if there's a traffic circle where you can change lanes, it's not really a modern roundabout. Quick sip of water. So I talked a little bit about the conflict points. I want to talk a little bit more about the speed. So in a traditional intersection, you have these conflict points, right? If you have somebody making a left, somebody coming through, say this person ran a red light or this person mistimed their permissive left. This first person making left turn, say they're turning at around 15 miles an hour because they're making a turn. But on our textile state facilities, it's very possible that this through movement could be 45, 50, 55 miles per hour. Plus, when I drive to Austin nearly every week, there's locations where this could be much higher than 55 miles per hour. That, of course, is going to be a very, very serious collision. Now, a roundabout, a multi-lane roundabout, you do have a potential of this crossing type conflict. You can see by the dots here, but the speeds are different. If this vehicle is circulating the roundabout at about 15 miles per hour, which is typical, the entering vehicle here in modern roundabout design should not be going more than 28 miles per hour. Our latest roundabout design guidelines say 30 miles per hour max for multi-lane. Our new roadway design manual is going to drop that down even more to 28 miles per hour max. So geometrically, our roundabouts should be designed that you cannot physically enter the roundabout at more than 28 miles per hour. Now that collision is going to be a lot less severe. And how do we know that? There's a mathematical model that predicts fatalities versus collision speed for different types of collisions. So the blue line in the middle is that T-bone or side impact collision. And what you can see here is at about 30 miles per hour, your risk of fatality skyrockets. And so that's where roundabouts get their incredible safety record. You have less conflict points, and the conflict points you do have are happening at low speeds. So even if roundabouts do have crashes sometimes, you're likely going to all make it home at the end of the day. The last thing I always hear about roundabout safety is drivers. Drivers are the problem, like nobody knows how to drive them. But those reduced conflict points, the low speeds, it makes it very forgiving for driveway error if you do make a mistake. I hear all the time, I don't have a problem with roundabouts. It's all the other drivers that don't know what they're doing. I always say, well, at least y'all make it home at the end of the day. Even in high-speed locations, this still applies. With good design, you can still get vehicles on a high-speed roadway, even 70 miles per hour plus, to slow down to 20 to 25 miles per hour entering. An FHWA study of 19 high-speed rural intersection conversions showed a 100% reduction in fatal crashes. It's a really incredible safety record. For roundabouts, there's more than safety. That's why I really love them. I wanted to highlight the big red box there, resiliency, something that really hit home for me the last week. We all experienced after Hurricane Beryl, the gridlock, right? With every traffic signal down, power out everywhere, and people trying to move around. People weren't hunkering down because they had to go get gas, they had to go get ice, they had to go get food. And so people were on the roadways and our signals were down. And I know Texas Houston District, valiant effort putting generators out at dozens of intersections, but we can't cover them all. It's very simple. A roundabout continues to work in a power outage. Because of that, Florida is actually installing roundabouts in so many locations. Florida's roundabout construction has taken off, and it's because they realize how they're resilient. This graphic actually came from Florida to talk about roundabouts. And in Florida, I mean, they've got, I think, the most aging population in the United States. So even with their older drivers, they're constructing roundabouts because not only the safety benefits, but because when they have multiple severe weather events every year, the roundabouts will keep working. Operationally, roundabouts are more efficient. The yield on entry better utilizes intersection space and reduces overall intersection delay. You don't have all red time. If you're sitting at a light next time and the other direction is still green and all the cars have flushed out and nobody's using the intersection space, you can think to yourself, man, if I was in a roundabout, I could go right now. So that also means reduced fuel consumption, less emissions. It's really a win for everybody. They are safer for pedestrians because of the slower speeds. And enhanced crossings at multi-lanes can also help those with low visibility or vision impairment. And then trucks. We talked a little bit about how roundabouts can have an advantage for trucks. That comes down to good design with truck aprons, your diameter, your approach geometry, etc. So let's dig in a little bit. This is my last topic before the end here. Accommodating oversized, overweight trucks. If you proper design paired with your truck aprons, you can really accommodate everything. An example on the right here, this is a small town in Washington State that has a major port and oil refineries on the other side of town. Twice a year, they have these big equipments come through on a self-propelled modular transport, like in the picture below. They do it at night. They have to shut down the whole town, take down a bunch of signals on span wires, but we designed the roundabout for it to essentially go straight through, and it was no problem when it went straight through. So again, This is a pretty small roundabout. That's only 110 feet in diameter. So with good design, you can pretty much accommodate everything. Another example I have is a state route, again in Washington State, a single lane roundabout, 150 feet in diameter, was put on a truck route. It was constructed as a truck route because Granite Falls was having dump and trailer trucks come through their town. I think it was 2 every minute on average. And so this poor little small town was just, buried in dump trucks, and they wanted a bypass. Under construction, we had this lowboy driver approach us and said, "Hey, I come through here twice a year bringing equipment in and out of the quarries. Do you think I'll be able to fit through the roundabouts?" And we went, "Ooh." We did a whole presentation at the time on lessons learned about finding your oversized, overweight vehicles during design and not during construction. But he met us out at one of the quarries. This is where the picture was taken. It's 112 feet long, 12 axles. And we measured him turning in circles so we could model the truck appropriately. We ended up doing one change order to widen an exterior truck apron. And then it came time to try it out. So I've got a video real quick that I can show. Can everybody see the video screen right now? Okay. Yeah. Seeing some nodding. Okay. You don't have to worry about sound. So what happened on the day of trying this truck out is the full alternate route hadn't opened yet. And so the truck needed to be able to pull a U-turn. And I want you to think back to that picture of a 112-foot truck. And I want you to see if you can think of any traditional signalized intersection where a 112-foot truck could pull a U-turn. And I bet you can't think of any because we don't design them for that. But in this situation, we gave it a try. We did modeling ahead of time. I was the one that did the modeling. That was actually a lot of fun. I was the one shooting this video. I think at this point, I started holding my breath to see if he would make it. So this red concrete here is a truck apron. It is meant for trucks to drive over. It had a 2-inch beveled curb, and it was colored to discourage regular vehicles, and it pretty much always works. People don't really want to drive over a 2-inch beveled curb in their passenger vehicle, but it's usually fine for trucks. Along the outer edge, you can see what his cab is hugging. That is a vertical curb. And so we did design it so that the truck would not have to drive over any vertical curbs. He would only track over truck aprons. And so here he is, you can see in this route, it was a 3-legged roundabout, and he couldn't make the exit onto the new route, so we had to do the U-turn. I can't even fit the truck in the whole video at this point. But at this point, I usually can't take it any longer. And anybody who's watching this video, I tell them that they don't hit the vertical curb. He makes it through. He tracks through on that truck apron just the way that he's supposed to. I believe we went out and measured. I think he drove through a puddle, and so we could see his tire tracks on the truck apron. And there was about 12 to 18 inches between that booster at the very end, his tires, and the vertical curve on the inside where you see the barrels. So I hear a lot of times, "Oh, I see that roundabout. I'm not going to be able to fit my trailer through there. I'm not going to be able to fit my horse trailer or my boat trailer through there." And I say, you know what? If it's designed properly, if we can accommodate a 112-foot lowboy pulling a U-turn, we can accommodate just about anything. Wind turbines are a whole different deal. You usually need to provide a path straight through like another truck apron. Here's an example of that dump and trailer that we designed it for, and they go through easy peasy. He doesn't even need to drive the front of his truck over the truck apron. It's just his trailer tracks over it. So I think they say a picture speaks 1,000 words, but a video speaks 1,000,000. So I think this particular video is a very powerful tool to convey roundabouts and how good design can accommodate just about everything. Next steps and takeaways. I think I'm a little bit over time here, but thank you for bearing with me. We're looking for ways to partner. Greater Houston Freight Committee, you guys are an important stakeholder for our program. We want to hear how we can make our designs and our program better. We're looking to reach out. We are working with like the Texas Trucking Association to talk with truckers. I had an excellent opportunity to talk on the Road Dog Trucking radio show yesterday. And I think they even want me back. So we're looking for ways. And if you know of ways within your realm of work that we can come talk, we can advocate, educate, or support, we would love to partner with you. And if I can leave you with anything, just remember that innovative intersections reduce fatalities, roundabouts save lives, and that's what we're working towards. With that, I can leave it on this slide for questions and just let this video run in the background so you can see. I like watching roundabout videos. I find them like a Zen garden, just watching the traffic flow. but this one has a lot of truck traffic, so that would be a good one. All right, I see a hand raised. I think there's also stuff in the chat. I'm going to go with the hand raised. I think Tyson, is that you?
Good afternoon, Amanda. Good to see you.
Good to see you too.
So what I do want to qualify for those that are listening here, that if there is a planned roundabout, UP does have specific standards to stay several hundred feet at least. I don't have the specifications in front of me, away from the rail right of way. UP doesn't view the roundabouts next to our right of way with our train operations as being the safest operation there. So when we're working with communities, we do ask that they stay away from our operating right of way there. I just want to qualify that those photos that Amanda did show in there with railroad right through the middle of them would not be something that would be permissible in today's standards. Is that fair, Amanda?
That is fair. I do know UPR has that standard. And the cover slide that I showed is not UPRR, it's a sideline. One of the things ITE is working on is we'd really like to change that conversation with UPRR, but we know it's going to take time. So that's a very good point. If you're doing one now, coordinate closely with UPRR and look at that distance very closely. I hope in the future that we can come to some standards that
meet everyone's needs.
Yes.
Yep.
Meets everyone's needs. Thank you.
I just wanted to make that qualification in case there are certain agencies that would come to us that might be a surprise conversation then. Thank you, Amanda.
Very good. Okay, so I looked at the chat. The chat was actually Shannon sharing our website links, so thank you.
Thanks, Amanda. I'll just say that, I moved about 3 years ago, but before I moved, we actually had a roundabout at the entrance to our neighborhood. And I never saw a kid get hit. I never saw a car accident. I lived there 9 years. It absolutely slowed down people. You don't have people going 50 miles an hour through your neighborhood. I go through the roundabout on Washington Avenue
Westcott.
and Westcott, and especially with the new changes that were made to the intersection, it absolutely slows down traffic. I've never seen an accident. And like you said, it's storm resilient. The lights were out up on I-10, and traffic was backed up at the lights, but you get down to Washington and everybody's moving because there is no traffic light. So big fan. We should build more. Appreciate you coming today.
Thank you. Awesome. Robert, is that you?
Yeah. I'm very familiar with roundabouts from England, where they're almost incredibly profuse. But one of the problems is, of course, that they take considerably more than just a four-way stop sign. And having just been T-boned, I'm extremely conscious of what happens when people run through. So I guess my point is there needs to be a consideration of how much land usage needs to be taken in order to have that much larger than a four-way stop sign in order to be able to do that. And I don't know whether right-of-way, whether the eminent domain, or how you could work that out. And I'm curious as to how that would happen in order to be able to expand roundabout usage into presently existent four-way stop signs without taking a lot more of the real estate. How do you do that?
As excellent question. When I hear people, I say, what do you think are reasons that a roundabout wouldn't work? I get a lot of reasons, but I think there's really only two main limiting factors to roundabouts. That's volume, traffic volume. More than 40 to 50,000 cars a day, a roundabout will be saturated. But that's high. There's a lot of intersections you drive through every day that's less than that. The second is right-of-way footprint. That said, there are a lot of states that are, I shouldn't say a lot, there are some states that are looking at, can we get smaller roundabouts with the same benefits? I know Washington State is experimenting with compact roundabouts on state facilities. Now I'll say, in my experience on textile state facilities, we often, the state, already have the right-of-way needed. Like in Houston District, we often on an FM road might have 120 feet of right-of-way. And so if you put in a roundabout, say 110-foot diameter,
Mhm.
you're fitting within that. Even if you're putting it a little bit bigger, you're talking about just a few corner clips. You know, one beauty of roundabouts is you might need corner clips at that intersection, but you only need them at the intersection. So say, for instance, if you're widening a corridor, we typically would widen the corridor, TxDOT would, with very wide medians to allow for U-turns. But if you put your U-turns at the roundabouts, your medians can be much narrower. That's called the wide node, narrow road concept. So over the course of a corridor, you would need more space at the intersections, but you would need less footprint overall because the whole width of the corridor is narrower, if that makes sense. So I think it's situationally dependent. I think the state, if we have bigger facilities, we have more luxury to be able to fit the roundabouts in. Local agencies with less room, or some of our rural districts with smaller right of ways. I've seen in our rural districts, it's a 2-lane highway with 60 feet of right of way. Then it's like, can we get the right of way, or can we get creative with our roundabout designs to do a more compact design that still has the safety benefits? And there's some options out there. One of the things on my wish list to come up with as a program is ways to scale down roundabout size and cost, because they're costly too. They're often more expensive than a signal to install. They'll pay themselves off compared to years of signal maintenance, but the immediate construction cost is higher. So I'd like to come up with methods, best practices for scaling roundabouts down and still achieving those safety benefits. Sorry, I could go on and on. Is that good?
Thank
That
you.
answer your question? Okay, good.
Thank you.
Yeah, Amanda, this is Richard Zentek with Union Pacific, and just appreciate your presentation. I did not get to talk to you at the Texas Freight Advisory Committee, but I did get to hear there, and I think at that time I was thinking of how my family and I had my wife and our kiddos had gone to Arizona, and that was the largest amount of roundabouts that I had ever, from the Grand Canyon driving to Sedona. But just seeing how the traffic flowed through those numerous, you got picked it up quick and got the hang of it as we traversed through there. So appreciate your presentation and learning more.
Thank you. I took a trip to Scotland a few years ago, and there were so many roundabouts everywhere. I love roundabouts. This is my job. This is my passion. And I was getting frustrated because I was like, can I drive more than a mile at speed before having to slow down for a roundabout? And so it's like, I know professionally that this is safe. This is helpful. And as a driver, I'm like, come on. And it's like, you know what? As a professional, I'm like, I kind of don't care if you get frustrated if we're saving your life, like it's that trade-off. So I can relate to drivers who maybe they're uncomfortable. I mean, you try driving through a roundabout going the wrong way over in England, it's mind-boggling. But so I can relate to the drivers, but like professionally, I kind of say maybe it was like this when seatbelts came out. People didn't like them. They were uncomfortable. I don't like this, but it's like, it's going to save your life. And I think it's the same with roundabouts. It's uncomfortable. You might not like it, but it will save your life.
Great. Thank you, Amanda. If there are no other questions, we appreciate your time today. Again, I thought this was a super great presentation, so appreciate your time and thank you. And Sydney, I think with that, we're going to go to the next thing. Tyson.
Yep. We have our last presenter, Tyson. He will give us Union Pacific Houston milestones, recent achievements, and future innovations. So I'll turn it over to you, Tyson.
Okay. Sydney, do we have any time restraints? Do you have something to cover after this presentation?
No, just future meetings.
Okay. So let me see if I can get shared screen here. I will not have as many slides as what Judge and Amanda had, but let me get set up here real quick. Okay, is everyone able to see my screen?
Yes.
Okay. So I thought it'd be appropriate real quick for those that don't know Union Pacific. We are over 160 years old. We've got over 32,000 miles of rail out there, and we operate in 23 different states. With that being said, Houston is one of our primary hubs and is very important to our operations. I have several roles with Union Pacific. I hold a hat of General Director for Network Development. And so that's what I've been doing for the last 7 years. And so I work very closely with TxDOT, local MPOs, the cities and regions for public projects or public-private partnerships there. I've been with Union Pacific for 28 and a little over and a half years. And so I've been in lots of different parts of Union Pacific. A lot of it's been on the commercial side. So that's part of what I'll speak to as far as the importance of the railroads in the Houston complex here. So with that being said, with Houston, one part of the strength that we have is all the different transportation modes. Judge Emmett started with the interstate network that you've got. We've got great pipeline. We've got great waterways with Bruce here representing the port, but we've got several ports in the region, right? And you've got a very strong rail network here. You have 3 Class 1 railroads. You've got CPKC, you've got BNSF, and you've got the Union Pacific. And then you do have some additional short lines that are here. So speaking a little bit from my general director role, but I'm also now leading the Port of Texas City down in Texas City here. And then we're a port and rail operation. And I also am a general manager for the HBT, which is also a real estate owner in the Houston complex, which is owned 50-50 by the BNSF and the UP. So that gives you a little bit of relevance as far as my background here. So a lot of people think of interstate systems and roadways when you think of the Houston complex, but I thought it'd be good to kind of start with just looking at the rail network. And so as you look at this, in the red is the UP. UP does have majority of the rail network in the Houston complex, but just because it's owned by Union Pacific doesn't mean that CPKC and BNSF aren't running on those lines as well. So many of these lines that you see that might be marked as UP, BNSF and CPKC run over as well. And so as you zoom in a little bit, I think something to keep in mind from a freight standpoint is that while the rail facilities support much of the local industry, understand that all of the growth that happens in Freeport, Corpus Christi, Brownsville, all of that freight that originates or needs to go to those ports has to go through this Houston complex. By definition and by our operations, that's what's happening here. So when you see freight trains, they're not all just originating or destined to the complex here, but there's much of it that's going through. So the Houston complex for us is very important for the growth of all of those regions and ports as well. So that's important to understand why the railroads are so important here. And so with that being said, when I think about Texas in general and Houston primarily, the majority of any of the growth from an industry standpoint within our 23 state franchise, the majority of it is happening here in Texas. And a lot of that's happening right here in Houston. And so that's what that translates for the general public is that means good paying jobs that are out there, right? And so that kind of gives the relevance of the railroads there. So Union Pacific, what I did is I had them run some numbers as far as what we put back into the railroad every year. And so over the last 10 years, we've put about a little over $3 billion back into the rail infrastructure. And to be fair, that does cover from Brownsville to New Orleans, but we don't like to get too specific on the dollars that we put into the area. When you think about that $3 billion, about $2 billion of those dollars go back into just renewal. So every year, so that we can run the trains, turn the lights back on, we got to put about $2 billion back into that infrastructure. Now, over the last 10 years, about close to $1 billion has gone into new capacity and new infrastructure. And so when I look at this map here, the areas that Union Pacific has put significant infrastructure into would be into our Inglewood Yard. And our Inglewood Yard would be right here where you see the East Belt here, but it runs east-west. And that's our primary classification yard. if something happens in that classification yard and it's not working well, they can feel those operational effects as far as LA or Chicago. And so, you know, Bruce, Catherine, myself, we are all part of a group called The Heart, and that's Houston Area Rail Transformation Group. And that's part of where we got our branding from, was because this is really the heartbeat of much of UP's operations. So when I think about, you know, close to $1 billion spent, we've spent significant dollars in that Inglewood yard, and that helps process all of the cars, like I said, coming from Brownsville area, New Orleans, as well as all of the industry growth that's happening here in the Houston complex. Now, another area that I'll point out that we've put significant investments into is what we call our Baytown branch subdivision over here. As many of you know, from a freight standpoint, there is a lot of growth happening in the Chambers County and Liberty County area. And so what that requires is significant investments, not only by industries to have rail capabilities, but rail as well, where we're looking to add additional double track. And you also see TxDOT putting a lot of investments in there. I think about, you know, the Highway 99 tollway that's over there that's, you know, helping with some of that growth. But we're collaborating with TxDOT on various grade separation projects like Highway 90 that right up here in Dayton, that there's Highway 90 that runs right through this Baytown sub connection. And that's been an at grade forever. TxDOT has the funding. They should be at 100% design later this year. And that will be a new grade separation that's going into place, or construction should start in 2025 there. And so and that is a project that has been out there for probably 20 some years. And so it takes a long time, one, for maybe a project to develop, and then two, to maybe find the right funding for it. So I just use that as an example where UP's has worked with the county, TxDOT, and other agencies to put a project like that together. And so when I think about investments and resiliency, there's other things that we've worked with TxDOT on. We just had the hurricane that came through. And I think understand that we depend on the local power supplies. And what happens when the local power supplies go out, all of our signal systems go down. And so Richard, who's on the call here, works very closely with the local power companies to make sure that, one, any down power lines get removed, but also that we get the power back to our signal system and lights and gates so that we can operate and the general public is safe there, right? Well, from a resiliency standpoint, we've worked with TxDOT for alternate fuel cell capabilities. As part of the storm, when all the power goes out, we don't just sit and wait. We have to go out and we deploy our own generators. And so when this storm hit, Richard, you might pipe in here, but it was well over 200 plus generators that were put out in our system in order to keep our network alive. Richard, I might have you jump in there.
Yeah, no, definitely, Tyson. And started the call, I was thanking everybody for understanding if we had, slow moving trains that were moving through at one point. I know we had to have flaggers, but definitely. I think it was over 500 generators that were out. We got that number down over the last 2 or 3 days to over 100, and continue to see that number decline as power is coming back up. But you're right. I mean, that is a momentous effort of us keeping our signal system going. And then just, anything that everyone else experienced as well. Was it power poles that were down, meters that were taken off of the poles, having to get those reestablished, working with the utilities, fiber lines that were hanging, not just in the Houston area, but, elsewhere further south as well, too. So all of those impacts that we saw definitely were felt on our railroad as well.
And then when I think about resiliency as well, I think of a lot of our rail network typically has been single main line. And so some of the things that we work on our own is to put double track in there. When I think about single main lines, I think of some areas like the east end of Houston, or even some of our communities along our Glidden Sub, which would be like your Missouri City, Sugarland, Rosenberg areas, where we have a lot of single track. And so some of our capacity projects help when we double track, because what that means is you can have trains moving both directions at one time versus having to have a train stop while another train runs around the other one. And so this is, again, where we're working with multiple agencies, TxDOT taking the lead on the studies and funding much of those, with active participation from county, city, and other agencies to see what kind of programs can be put together, one, for grade separations, or two, maybe it's helping the railroads be more resilient and add additional double track. And so we'll be looking at those studies. The Glidden Sub study is kicking off this summer, so they're starting that one. We've already done a phase 2. I don't believe it's been published yet, but that will really focus in on this east end, where we know that there's areas where there are block crossings, and we're looking for what those types of solutions can be. Catherine's on here, and part of the Heart Group. She's been successful in securing the funding on the West Belt here for several grade separations on Commerce Navigation, and then also for York Sampson for those 2 grade separations. So those are projects that are now fully funded, that still need to go through the design process. And so the design process will take a couple of years, and then those will go to construction. The other grade separation that is being designed right now by TxDOT for multiple agency benefit would be the Griggs-Long-McCalla grade separation. And that is right at where our Harrisburg sub connects with our West Belt and the BNSF's McCalla sub. Now, this is a very complicated grade separation that's going to take place here, because you have city roadways, you have a future metro capability that they would like to be able to get to the airport through here, and then you have a TxDOT project that's putting a new highway in there. And so this is going to be basically 4 levels, with the freight railroads at the base level. You'll have metro above the freight railroads, city streets above metro, and then TxDOT at the very top. It's very complicated, and it's going to be very expensive. I think we have the cost estimate at about $120 million for that grade separation. But if anyone's traversed those roads in through there, it looks like a spaghetti bowl, very complicated. And so it's very neat that this has been identified as one of the probably, top tier as far as from a safety standpoint to get fixed at some point for many, many years, right? But it's because of what we have here in Houston. The Heart Group and other HGACs been a huge supporter of this, to bring everyone together so we can get common goal and the right kind of funding. And so there will be local funding matches, which will include the railroads, as well as we're looking for federal match money in order to help make that project move forward. So that is just kind of an overview as far as, what UP's been investing into the Houston complex, to how we've been working with the local agencies and, trying to look at solutions for the Houston complex. I think many times Richard may get deemed as, the villain of that we're not participating and trying to find solutions, but we're actively doing that. I know, from my perspective, I've had this role for the last 7 years, and we've tried to be very strategic on, finding solutions and working with the various agencies. So we appreciate the time to kind of, talk high level on the UP network. So I know we've got a couple of minutes left here. I'll open it up for questions, anything that you might have for me.
Thanks, Tyson. And I'll just say, the UP has been a great partner in creating the Heart and really looking at grade separations and potential public benefit operational improvements on their railroad and the railroads in Houston in general. Tyson alluded to it at the beginning of his conversation about how important all of the modes are. If you took rail out of Houston, you'd probably add 9 million more trucks a year onto our road network. So we're in a great spot having great railroads here to operate in and around our region. So if anybody has a question, please chime in or raise your hand. Well, I guess you did a great job, Tyson. There you go. So
Thanks, Bruce.
thank you, Tyson. Appreciate it. And Sydney, I guess if you want to take us to announcements. And you're on mute.
Okay, great. Thank you. So for upcoming meetings, our next Greater Houston Freight Committee meeting is scheduled for October 17th. We're still hoping that this one can be a tour, but stay tuned for more information on that. Here are some other meetings that are taking place: the Regional Air Quality Committee, Transportation Policy Council, Transportation Advisory Council, and the Safety Committee are all meeting. And then this month, the Texas Freight Advisory Committee is meeting in person, I believe, in the DFW area. So I will turn it back over to you, Bruce, for any last comments and to close us out.
Richard, why don't you go ahead? I got the beginning. I'll let you close us out in the end.
All right, well, I'll be quick, but appreciate everybody's time. Thank you to all the presenters. Great information that was shared today. If you have any other questions, feel free to follow up with me, Bruce, or Sydney. So I hope everyone continues to recover well, and thank you for your time. We'll see you in October.
Thank you.
All right,
Thank
thank
you.
y'all.
Thank you.
Thanks, everybody. Great presentations.
Yes.
Thanks, sorry.
Bye now.